Okay, here we're going to be finding the complex root, and so we have our complex number w, r is our radius, theta is our angle, and we're going to be finding n distinct complex roots. Now n, our number of complex roots, must be greater than or equal to 2, and it must be an integer, and our complex number is not equal to 0. So we have our formula here where k, we're just counting up, we start at 0, and we're counting up those roots. Here we're taking the nth root of r, remember n is our number of complex roots, and we're dividing our angle by n, and then here we take our laps, and here's our value k, counting that up. So we're going to do an example, and we'll do more of these in class. For this example, we're going to find the cube roots of -1 plus square root of 3i. So let's first start off, let's change this into polar form. Now if we were to graph this, we know that our -1 is going to take us over here, square root of 3 goes up, square root of 3 here. So this gives us our point, that's our right triangle. We can now use Pythagorean theorem, find that our radius there is 2, and this is our angle theta that we're looking for. So we can either use sine of square root of 3 over 2, or sine of theta equals square root of 3 over 2 to find this, or cosine of theta is equal to -1/2. We find that our angle is 120 degrees. And we have our radius of 2. So now if we're going to write our complex number w, so we have 2 and the cosine of 120 degrees. And our sine of 120 degrees. And so now as far as finding those the cube roots here, so we're going to start off, so we're saying that we have our first root where we plug in 0. So with this formula we start our k values at 0 and count up to n minus 1. So n, remember, is our number of roots, and so in this case we're talking about 3 of them. So we'll have 0, 1, and 2 that we plug in for our k values. So here we're going to have the cube root of 2, and then we're taking our angle of 120 degrees and we divide it by 3. And because we have our k value as 0, so now this is one of those cases here where we're taking this times 0 because we're not taking a lap. This is our first root, and we're doing that for both sine and cosine for that angle. So our angle is going to stay the same here. So we're saying 120 divided by 3 plus 2 pi times 0 over 3. And that's going to find it there. So if we simplify this, we have the cube root of 2. And then here we're going to have cosine of 40 degrees and the sine of 40 degrees. And that would be our first root. We're now going to do the same thing here. We're going to have our k value now equal to 1. Taking the cube root of 2 again. And now when we come in here and we plug in our angle, so we have our 120 divided by 3 plus, now we set our k value is equal to 1. So we're taking that lap there, still divided by 3 because it's cube root. And we're doing the same thing over here with sine for that angle. So if we simplify that, cube root of 2 here, and now our angle is 160 degrees. So now I want you to go through and do the same thing, plugging in those values. So now our k value is 2. Pause the video, plug it in, see what you get, and we'll check our answer. So looking at our angle on this first one, we had 120 divided by 3. That gives us our 40 degrees, and because we're multiplying by 0 here, then this goes to 0. If we look at our second angle, again we have 120 divided by 3 gives us 40 degrees. And now we have one lap So 2 pi is 1 lap, that's 360 degrees, and then we divide it by 3. So we're adding 120 degrees. So that's where that 160 comes from. So now looking at our third root, again we have 120 divided by 3, so we have our 40 degrees. Now we've taken 2 laps, so we have 720 divided by 3, which is going to add 240 degrees. So that's where we get the 280. Now what this is saying is that we have these 3 parts, if we're thinking of this graphically, and our first one is what we're starting with. Our original, we have a radius of 2 and our angle's 120 degrees. So if we look at that, we're saying 120 degrees, and then here's our 2, there's our 120 degree angle. Now if we look at each of these roots, the cube root of 2 for each of them would then give us the same magnitude. And then our angles, we have our 40 degrees, so that's going to come off this direction. So we have 40 degrees, and then that cube root of 2 here. And then we have 160 degrees. It's going to come off this direction, and again, cube root of 2 here. And then we have our last one coming off this direction. Again, cube root of 2, and now that's our 280 degrees. And when we put these all together, multiply them all together, our resulting piece is the angle that we had began with. Again, we'll do more examples of this in class, but what we're looking at are the complex roots of this given number. Here we have Dumont's theorem, and what we're doing is we're taking our complex number z, and then we're going to raise it to a power n. And so what we'll do, we're going to do an example here, but if we have our complex z raised to the nth power, then we're going to raise our radius r to that power, and then we're multiplying our angle by that same number. So for example, here we have 2 times the cosine of 20 degrees plus I sine 20 degrees, and what we have is now we're going to cube this complex number z. So if I take 2 cubed, and then we have cosine of our angle of 20, we're going to multiply that by 3, and we're going to do the same thing over here with sine. So we have our angle of 20 multiplied by 3. So this gives us 8. And now we have cosine of 60 degrees and the sine of 60 degrees. Now we're asked here to write the expression in standard form. So at this point we can take the cosine of 60 degrees and the sine of 60 degrees. So we know cosine of 60 is equal to 1/2, and the sine of 60 is equal to square root of 3 over 2. And now if we distribute, we end up with 4 plus 4 square root 3 I, and now we have our answer in standard form. In this example, we have our complex number square root of 3 minus I, and again we're raising this to a power. In this case we're raising it to the 6th power. First thing we're going to want to do is rewrite this in polar form. So if we start by drawing our triangle, we are going over square root of 3, and we're going down 1. And so we need to use Pythagorean theorem to find r. I know r squared is going to be equal to square root of 3 squared, which is 3, plus 1. So that gives us 4 here. So square root of that, we find that r is 2. And now we can also find our angle here, theta, and we could use either sine of theta is equal to negative 1/2, or we could use cosine and get square root of 3 over 2, and you find that our reference angle is equal to 30 degrees, or negative 30 degrees. So now if we're looking at our complex number written in polar form, we have 2, and we have cosine of 30 degrees and the sine of 30 degrees. And now when we take this to the 6th power. So we're going to have 2 to the 6th, and then our cosine is 6 times 30, and sine is 6 times 30. So 2 to the 6th is 64, and 6 times 30 gives us an angle of 180 degrees. Cosine of 180 is -1, and the sine of 180 is 0. So now when we distribute here, we end up with a -64.